Okay, finding the 54th derivative of this function. Okay, so what we'll do here is take, 3 or 4 derivatives and see if there's a pattern. Maybe more than that, maybe 5. Okay, first derivative, f prime of x is minus sine 2x minus 5 times 2. Okay, f double prime of x is going to be minus cosine 2x minus 5. And I have another 2, so I'll square that 2 that was already there. Continuing, third derivative. Let's write that as a 3 exponent. Plus sine 2x minus 5, 2 cubed. Fourth derivative, cosine 2x minus 5, 2 to the 4. Let's try to guess what is going on here. Okay, now looking at the first derivative, we got minus sine. Then second derivative is minus cos. Third derivative is plus sine. Fourth derivative is plus cos. Notice how I've come back to where I started. Okay, I started with plus cos, and now I've come back to plus cos on the fourth derivative. So from this, I deduce that on the eighth derivative, I will also come back to cosine, plus cosine. But now, what power of 2 am I going to have? Well, the pattern here is hopefully easy to see. Okay, when you're doing a fourth derivative, you have a 4 here. When you're doing a third derivative, you have a 3 here. So when I do an eighth derivative, I have an 8 here. Okay. Now, what does that mean? Well, it's a cycle, we say. And the length of the cycle is 4. So where's 52? 54. 54 is not divisible by 4, but 52 is. 52 divided by 4 is what, 13? Yep. So what does that tell me? F to the 52 of x is going to be plus cosine again. And then 2 to the power of 52. So f to the 54 of x is going to be, well, if you follow my green pencil crayon here, 52 is like my original, right? It's like plus cosine. 53 would be minus sine, and then 54 is going to be minus cosine. So just recognizing the pattern here. 2 to the power of 54. Okay, that seems right to me. Let's just double check to see what the answer sheet says. Yeah, good. Okay, next example. So when does f of x equal to 3x e to the 1 minus 8x squared? Ooh, have a horizontal tangent. So Horizontal tangent, f prime equals 0. So I find f prime, set it equal to 0. F prime requires product rule. So I do that, e to the 1 minus 8x squared times the derivative here, minus 16x. Okay, I'm setting that equal to 0 and solving, so I'm going to have to factor here. With product rule, as always, I got two terms, 1, 2. What's the common factor? Looks like 3 and the exponent. So I get 1 plus, no, not a 3, x times minus 16x. That's what's left there. Now we use a little piece of logic here. We say either 3 times e 1 minus 8x squared is equal to 0, or this 1 minus 16, oh my goodness, 1 minus 16x squared is equal to 0. Okay, where this is that thing right there. So when is an exponential equal to 0? Well, if you think of the graph of an exponential, the answer is never. So there's no solution coming from that guy. But over here we have x squared is equal to 1 over 16. So x is equal to plus or minus a quarter. Yeah, good.